Today we shall demonstrate how to use the oscilloscope. Oscilloscope can display a voltage waveform in time, and you can perform a number of operations like measuring the amplitude, frequency, phase, and you can also add, subtract, integrate or differentiate waveforms using oscilloscopes. First, what we have to do is we have a sinusoid 5 sine 2000 pi t, so its peak amplitude is 5 volts and frequency is 1 kilohertz. We have to set up the signal generator so that the output is 5 sine 2000 pi t, and we shall display it on the oscilloscope. This is the AC signal generator part. So first we have to select the waveform sinusoid. So for sinusoid output, both these buttons will be in upright position, and if we need triangular, then we need to press this button. If you need a square wave, then we just press this button. But if we need sinusoid, then both these buttons will be in upright position. And this knob is for adjusting the amplitude, and this is for adjusting the offset. And these buttons are frequency range buttons, so we have to select a range close to our desired frequency, and then we have to use this frequency vernier knob to adjust the frequency. So what I'm going to do is I shall first connect the oscilloscope probe to the signal generator. The oscilloscope has two channels, channel 1 and channel 2. I am now using channel 1, so I am turning channel 1. I am activating channel 1 and I am connecting it to the signal generator. The red cable should be connected to the red port, that is the signal, and the black to the black port, that is the ground. Now I need a frequency of 1 kilohertz, so I select the range button for 1 kilohertz, and this is the frequency. Now I have to, because now the current frequency is 1.24 kilohertz, so I need to adjust it so that the frequency becomes 1 kilohertz. Okay, so the frequency is now 1 kilohertz, and as you can see that from the display of the oscilloscope, there is a sinusoid with frequency 1 kilohertz. So the peak to peak voltage is now approximately 2.7 volts, but we want a sinusoid that has a peak amplitude of 5 volts, that is peak to peak amplitude will be 10 volts. So we need to increase the amplitude. So as we increase the amplitude, we see the voltage swing is going out of the range of the display. So what we have to do is we have to adjust the vertical scale of the display of the oscilloscope. So now the volts per division setting is 5 volts per division, that is 1 measured division equals 5 volts. So using this knob, we can choose the vertical scale of the display of the oscilloscope. It is also called the volt per division knob. So we need peak to peak amplitude of 10 volts corresponding to peak amplitude of 5 volts. okay, you can leave it. It is approximately almost 10 volts. And another important thing is the trigger. The trigger can be activated using this button. So we can trigger the display on the rising time, and also we can trigger display when for falling edge or rising edge. And now the waveform is displayed using channel 1, so we have to select trigger for channel 1, and the trigger level can be adjusted using this knob. We can see the trigger level as indicated by T on the display. It is very important that the trigger level is within the range of the voltage swing. If the trigger level is outside the voltage swing, then there is no stable display of the waveform. So the trigger level must be kept within the range of the voltage swing. And we can also measure amplitude, frequency, phase, etc. using the oscilloscope. Quickly, for quick measurements we can use the quick measure function. So once you press this, the quick measure function we can use. So first of all, once we select to use quick measure, we need to select the source. Now we are using channel 1, so we have to select the source as channel 1, and now we shall select what we want to measure. Using this knob, you can select the parameter that you want to measure: amplitude, average, fall time, frequency, peak to peak, period, phase. So a number of things can be measured using the quick measure function. So let us measure amplitude. So the peak to peak amplitude is now 10.25 volts. But we can also use cursors to measure the time period, amplitude, frequency, phase, etc. The cursor function can be activated using this button, and once the cursor is activated, we need to select whether we want to use the cursor for measurement along the vertical axis or the horizontal axis. The horizontal axis is the x-axis that corresponds to time, and the vertical axis, that is y-axis, it corresponds to the amplitude of the voltage waveform. Using this, we can select the cursor function for either horizontal axis or vertical axis. So let us first use it for measurement of time period. So a time period is the time in which the voltage waveform completes one cycle, and this is the time between two positive peaks or two negative peaks. So we select to measure the time between two consecutive positive peaks. So now we set x1 at the first positive peak, and then we select to move x2 to the next positive peak. So now delta x, that is the difference between x1 and x2, is 1 millisecond, which corresponds to a frequency of 1 kilohertz. And we can also use the cursor to measure the amplitude in the vertical axis. So we want to measure the peak amplitude. So the peak amplitude is the amplitude between the ground level and the peak. So we move y1 to the peak of the voltage waveform, and we put y2 ground level. The ground level is indicated by that 1 indicates that is the ground level for channel 1. So the peak amplitude is, as you can see, delta y equals minus 4.93 volts. It is minus because y2 is at ground level. If we put y2 at the positive peak and y1 at the ground, then you will see the amplitude is positive.